Welcome to Lesson 5.1, Rates and Unit Rates. This comes from our Math and Focus textbook for 6th grade. This is the extra practice assignment that recently went home with students in our 7th grade math classroom. And hopefully you're finding that using this bar model strategy is becoming more comfortable and that you are prepared to give us some labels and some words back. So I'm going to take a minute or two to set up just a few problems with you to try to get you started. Here it says solve, show your work. So again, I reminded students in class today that for us, that means we want to show a bar model strategy. This is going to help students to identify whether we are increasing to a rate or decreasing to a unit rate, whether we will multiply or divide. Besides bar models, I'm also looking for labels. So please make sure that when they give us words, you give words back. Number one, it takes 8 minutes for water from a tap to fill up a 30-gallon tank. What is the rate of water flowing from the tap per minute? Ooh, I hope you just glued yourself to these words, per minute. That means in a moment, I will divide by minutes. There's a big clue to us here. That also tells me that I'm probably going to want to use my minutes, this 8 minutes, as my unit label. So I'm going to start my bar model, but I'm going to go ahead and label it 8 minutes. Well, 8 units makes sense with that for me. So 1, 2, 3, 4, 5, 6, 7, 8 units. And during that 8 minutes, what can happen? Oh, we can fill a 30-gallon tank. Now, if they ask me then, what is the rate? They're actually asking me, what is the unit rate? This is a long bar, and they're asking me to figure out how much I can fill in the tank in just 1 minute. So again, notice we are going from a longer bar to a shorter bar. We're going to have to use some division to get here, to go from a rate to a unit rate. That will not always be the case, but that is a real reason why I like these bar models for you as a strategy. Well, in this case, the total, or the total quantity that we're given is 30 gallons, and I'm going to divide that into the 8 little units or 8 little minutes that we're given. 8 does go into 30, and there's going to be something left over. You're actually going to have to write this as a mixed number or possibly as a decimal answer in a minute. Either one would be acceptable because we're given whole numbers in the problem, so either a mixed number or a decimal answer would be acceptable. 8 doesn't go into 3, but it goes into 30 3 times because 8 times 3 is 24. When you subtract, you're left with 6. And if you take a look, that could quickly be written as a mixed number. So I could write that as 3 6/8. But I hope you notice that's not a good final answer. We could actually simplify to 3 3/4. We did that by dividing the top and the bottom by a common factor of 2. Well, this is better for number value, but it sure doesn't answer the question. So what is the rate of water flowing from the tap per minute? Oops, I'm trying to write this out for us, and my pen doesn't really want to write for us right now. Let's try that again. The rate of water is 3 3/4. What were we measuring in? Oh, we have 2 units. We have gallons and minutes. And if it says per minute, we know that that's going to be the second part of our label. So the first thing I need to say is gallons, 3 3/4 gallons per minute. Not only that, in my label, if I'm using this word per, I'm also showing you that I found the unit rate. Here's an answer for number 1. Now someone else might notice that I could go ahead and take this to decimal land. I could go ahead and divide 60 by 8 here and get to a decimal answer. That would also be a decent way to solve. Let's take a look at number 2. So let's see if I can scroll there for us. Number 2. A photocopy machine can print 735 copies in 7 minutes. What is the rate at which the machine prints the copies per minute? There we go again, per minute. We're going to have to divide by minutes. Let's go ahead and set this up then. It talks about 735 copies, that's important, and 7 minutes. Well, I can picture 7 minutes, that's how many units I want to draw, so I will label that to the left. Make sure I have 7. I think I'm good. And we're going to go ahead and label the top here. That's the total number of copies I can make. Copies. Notice I am giving these labels on my bar model just because that will also help me to answer my question in just a moment. Well, if they're asking me what is the rate, meaning how quickly is this printing, they're trying to break this down into a single unit or into 1 minute. We're going to find this answer in just a moment. So once we have this bar model, we have two numbers to work with, and because it says per minute, I know I need to divide by the 7 minutes, and I need to make the 735 my dividend. So let's give this a try. 7 goes into 7 one time, with nothing remaining. 7 does not go into 3, so we need to show that we tried. But 7 goes into 35 5 times, and 5 times 7 is actually 35, with nothing remaining. We have a number answer, it looks like a whole number, but you need to remember, not only do I expect bar models from you today, I expect to see words back. So 105 what? Well, we need to give 2 labels for every answer. We practiced it in our notes, but you need to practice it now or show me your independence with it. Something per something, right? 2 different labels. So here I have copies and I have minutes. If you take a look, because it says per minute, it already completes the second part of your comparison or of your rate. And the first label that we're missing is copies. There's another way to think about the order that this has to happen in. So 105 copies per minute is acceptable. It probably would be better to say a photocopy machine can print. So a photocopy machine can print 105 copies per minute. That's a good final answer. I've given you a label, and this label has 2 parts. Notice I have to talk about the copies and the minutes. I didn't really emphasize that on number 1, but every label here, if we're talking about a rate or unit rate, needs 2 parts, 2 different units that we're comparing. Number 3, it took 9 gallons of gas for the car to travel 216 miles. What is the rate of the car in miles per gallon of gas? Ooh, I noticed something. Miles per gallon is already written here. Per gallon, we're going to divide by gallons. Big clue to me. I can find that in the question real quickly. Well, now I need to set this up. It says 9 gallons goes with 216 miles. Well, if I'm dividing by gallons, it's also telling me that's how many units. So I'm going to label this 9 gallons. I'm going to try to draw a quick sketch for you. And with those 9 units, I know I can make it 216 miles. So again, 9 gallons goes with 216 miles. It's labeled on my bar model. If they want to know the rate of the car, meaning how quickly can it go, they keep asking these same questions. The rate, the rate, the rate, find the rate. How quickly is it happening? They're actually asking for a unit rate. And I think that can be kind of dangerous with all these bar models. I found that students get kind of confused when we start switching between rates and unit rates. So this idea of a quick sketch is a real safe way to show your thinking and make sure you're getting to a good final answer. Again, you would take the total, you would divide by the number of units or gallons in this case, and you would have to give me a 2-part label. So the last one we had was copies per minute. This one's going to involve miles and gallons, and you want to make sure that you're giving me these labels in the appropriate order. So big clue, right here it says miles per gallon. They're really hinting to you the order that this goes in. This one's actually stated really well for you in number 3. Let's see if we can fast forward here. Oops. We'll take a look at number 4. Number 4 says, a car traveled a distance of 192 miles from New York to a small town in Pennsylvania in 3 hours. Find the speed of the car. So the car is traveling this distance. I don't have any magic words per, do I? But I do have a total distance. 192 miles is how far it made it, and a total time. Okay, so I have time and a total distance. There is a triangle strategy. I sometimes call it the dirt triangle. That would work really well for this, where distance equals rate times time, or distance divided by rate gets me time, or distance divided by time gets me rate. That's one possibility. We didn't get to look at that in our notes today, so if that's something that you're not comfortable with or haven't seen before, we don't have to go there right this moment. Another way would be a nice bar model. So if we know 3 hours is talking about the amount of time, and we're talking about speed where we compare rate to time, I'm going to go ahead and label my 3 hours here as a number of units. 3 hours is my units, and the total distance is this 192 miles. Well, if they're trying to figure out the speed, they really want me to break this down into a single unit, also known as a unit rate. So they want to know how fast I'm going per hour or in 1 hour. I'm trusting that you're going to know how to set this up at this point. So again, looks like I'm going to have two numbers to work with, my miles and my hours. And I really want to think about speed, and what I remember about that is miles per hour is really how we measure things quite a lot. Oops. Let's see if we can get to the next page. Number 5. Ms. O'Leary pays $969.50 to stay 1 week in a hotel. What is the room rate per day? Big clue here, per day. What are we dividing by? The number of days. Well, this could be a problem or kind of tricky because there are no days listed. It talks about 1 week. Oh, I bet we could convert 1 week into days. How many days is that equivalent to? 7 days. I'm going to ask you to try to draw me a quick bar model. I want you to sketch out the two pieces here. So I should see a number of units. I should also see some decent labels. A label that goes here with my bar, it talks about how many units, and a label that goes here, it talks about a different type of measure that we're comparing. This is what is the room rate per day. They're talking about just one of these little tiny days in a minute. So in 1 day, we'll be able to figure out how much the cost was. There is a decimal happening here, and I think when you go to divide, you will find that that decimal can move straight into your quotient. Okay, just some hints for you. I do believe that these questions are very doable. I do believe that as 7th grade math students that you should be heading on the right track. I don't think that there are any big surprises between here and there. But I do want to look at number 7. I do want to caution you. And when my students keep asking, how come the bar models, how come the bar models, number 7 is a real reason for a bar model. Okay, so kind of tuning in here. A wheel makes 40 revolutions per minute. Something's different here. This just said per minute. What that means is in 1 minute. At this rate, how many minutes does it take for the wheel to make 280 revolutions? So if I were to sketch this out for you, I'm not given a rate. I'm given a single tiny minute. I'm given a unit rate. And during that time, I can make 40 revolutions. Well, then if they ask me, how many minutes does it take to make 280 revolutions? I want more revolutions. I want to figure out what it would take to get to 280 revolutions. And the question is sitting here. This is a different setup than before. I think this bar model will absolutely help you see it. I think that you can see that we're going from a smaller bar to a larger bar. So in this case, we're going from a unit rate to a rate. And before, we used a different strategy to get there, so you might want to be a little bit careful about that. I might start thinking about how many of these might fit in here. And this almost looks like the process of division, doesn't it? So a little different procedure here, a little different setup that we're starting with a unit rate bar going to a rate. Don't forget that when you're done, I need to see an answer. And not only that, your answer needs to have multiple labels. Okay, multiple labels. I'm kind of struggling because I'm trying not to give this away. I probably am not going to have the word per in here, am I? I can't use the word per, right? Because per we'd have to deal with 1 minute or a single unit rate. So I might have to use the word for, or I might have to use the word to complete. Something along that line. I'm going to have to change my verbiage a little bit. All right, let's take a look at number 8. See if we can get you a quick setup and get you going. If you're struggling, hopefully things are going pretty well for you at this point though. Most of those problems are pretty familiar. The flow rate of a water pump is 2.8 gallons per minute. Oh, here we go again, per minute. That means in 1 minute. Take a look. This one is starting with a single unit rate. So I'm going to label this 2 8/10 gallons. Oops, I did that wrong. Usually I don't put that label over here, do I? I'm going to backtrack a little bit for you. This 1 actually represents 1 minute. That's what I'm measuring my units in. And during that time, I can fill 2 8/10 gallons. I just grabbed that first sentence and I was able to sketch it out really quickly. How many minutes does it take this pump to transfer 84 gallons of water out of the swimming pool? So again, they're asking how many minutes. I'm going to transfer more water. How much water are we moving? 84 gallons. Notice my gallons were along the top of this bar, so my gallons are along the top or the bottom of this bar. And the question is, how many minutes? You're going to want to use the same strategy as you saw on number 7. You're going to want to take a look that we are going from a unit rate to a rate. This bar is getting longer, right? This bar is bigger. What we're trying to say is how many of these 2.8s would fit in here and so on. And not literally, this is really just kind of a visualization to kind of get me thinking along that line. So 7 and 8 are going to be more challenging for you, and I am purposely going to kind of push you in that direction. See if you can give us a good answer, and be sure you answer with word form. So give me words back. Number 9, I'm not going to demonstrate for you. I'm thinking that even though it has multiple parts, you're going to be able to handle this just fine. I think a bar model would make good sense. They're telling me about a fax machine, how many pages it can send in 6 minutes. I can picture that. 6 minutes is probably 6 units. I'm already in my mind in a good spot with that, and I hope you are too. I do want to take a look at number 10, and I kind of want to just emphasize mental math in this situation. I do love for my students to show their work, so there's a way to kind of do that and also include the mental math along the way. Megan earns $9.50 per hour. Ooh, per hour. That means for each hour. Or this is a unit rate. For each one of those hours, this is a unit rate. She's working at a daycare, complete the table. So if she works 1 hour, she's gonna make $9.50. Well, what if she worked 2 hours? Would she make more or less? Well, obviously, we're gonna double this amount, so we're also gonna double over here. But I wanna talk to you about this $9.50 and how close it is to what? $10, right? So $9.50 plus $10, just thinking, I probably wouldn't even write this on my paper, but maybe to show you my strategy, I'll do that real quick. That would get me $19.50, wouldn't it? But I'm not actually adding 10 whole dollars. I need to take away the extra 50 cents that I kind of added on here, again in my mental math strategy. So then next I'm going to say that sum, take away 50 cents. This is the way I'm going to think about it. I'm going to add 10 each time and then take away 50 cents each time. So I'm showing you my mental math strategy over here. If you don't like that, you can actually take these decimals and start multiplying. It will also work. $9.50 plus $10 is $19.50. But take off that 50 cents extra, we are at $19. Let's try it again. Mental math, the same strategy. $19 plus $10. Oh, that's $29. But I need to remove that extra 50 cents. $29, take away 50 cents. $28.50. Okay? You could also check that with multiplication. You could also take this $9.50 times 3, and it should also check out. Just like here, I took my hours times 3. It checks out. I want you to continue either the mental math strategy to fill this out, or maybe off to the side, you're multiplying some decimals. Remember to build a decimal bank if you're doing that, or if you decide just to add continuously, you can bring your decimals straight down. You should be able to answer part A and part B in just a moment. How much will Megan earn if she works 4 hours? Well, I haven't answered that for you yet, but the answer will be sitting right in this column. Or sorry, this is a row, isn't it? And then it says how many hours will Megan have to work to earn $28.50? I already see that answer. It's somewhere on my table. So be sure you're answering with the correct label. How many hours? I need to answer in hours. How much will Megan earn? Oh, how much? They're talking about money. Watch your labels for part A and part B. Make sure you give me words back. In this last section, I'm just going to remind you of a skill that I taught you in class when I saw you last. It says this table shows the cost of 3 different fruits Ian purchased at a grocery store. Round your answers to the nearest hundredth of a dollar. So we have grapefruit, we have rhubarb, we have cherries. We know how much is paid for the grapefruit. We can see how much was purchased, but what we don't know is the cost per pound. Per pound. Oh, hint, divide by pounds. I also hope that you're thinking back to your notes and a really awesome song that I taught you, which is put the money in, put the quantity out, put the money in, and divide it all about. This will find you what's called a unit rate, or we call it a unit price when we're talking about money. So we're finding a unit price right now. The way to do this every single time is to put the money in, put the quantity out, and we're going to divide it all about. I've got the first one set up for you. You're ready to go. I will caution you, well, that will work just great for grapefruit and rhubarb because we know the total amount, the total quantity. I just did that wrong. Well, we know the total amount paid, we know the money, and we know the total amount purchased, the quantity. Part 3, or these cherries aren't quite the same. I'm missing the amount paid. I don't know it. So what I do have is the quantity and the cost per pound. I'm going to have to work a little bit differently. So if every single time I move in this direction, I'm dividing, I wonder what we're going to have to do if I'm moving backwards. So I do want you to be careful when you're thinking about that. You're going to have to think about an inverse operation, or doing the opposite. So those are my only hints to you. Think of the opposite of division. If we're moving in this direction, we do divide. Put the money in, put the quantity out, divide it all about. But if we're moving in the opposite direction, you'll have to try an opposite strategy. You should, when you're done, be able to tell me which fruit costs the most per pound. But I would really encourage you to take a look at the column that talks about per pound. The cost per pound. This column is going to be your friend for Part A. Next it says Part B. What is the price difference per pound between the most expensive fruit and the cheapest fruit? Again, it says per pound, the price difference per pound. So I'm going to grab that information also for Part B. That's going to come from this column, this last column when I'm done. I have students every year that grab the wrong information. They love to grab the amount paid and do some difference work there, or they like to talk about the amount purchased and do some difference work there. That's not what they're asking for, so do be careful. I am expecting not necessarily bar models for Part A and Part B here, but I am expecting words back. So make sure you have some solid labels when you're done. I hope that you are feeling more fluent when it comes to rates and unit rates, and how to apply those bar models to help you visualize a strategy. Those students who keep asking, why the bar models? This is why. It helps you visualize which step to take or what strategy to apply.